For this example, we're going to sketch a graph of g of x equals 2 minus 3 times cosine of the quantity x over 2 plus pi over 4 for at least one period. First thing I'm going to do is I'm going to factor out the effects of the period change from the inside of this function, meaning I'm going to take the function 2 minus 3 cosine of x over 2 plus pi fourths, and I'm going to factor out on the inside the value that is multiplying x, which is that 1/2 there. Meaning I'm going to rewrite this as 2 minus 3 cosine of 1/2 times x plus pi over 2. If you would like to go one step further for more familiarity, you can also, if you would like, move the constant term of 2 to the end. Some individuals prefer to have this in the same format as most other trig functions of this type and have the constant, the vertical shift, listed at the end. From here, though, I'm going to create a t-table and use the t-table method to come up with a graph for this. To start off with the t-table, I'm going to begin with x and values of just cosine of x, not this function, just cosine of x. And I'm going to use the 5 quadrantal angle measures. So 0, pi halves, pi, 3 pi halves, and 2 pi. And if you plug each of those into cosine, you will get the values 1, 0, -1, 0, and 1. From here, we're going to adjust both my x values and my values for cosine of x. The middle line I have here, consider as an unbreakable barrier. I'm not going to cross that. The values and operations I'm going to do are simply going to affect y or x independently. I will start with the y values, or the cosine of x values. The first thing I'm going to do is apply my amplitude. Now, my amplitude comes from the number that is multiplying your function, which in this case is a -3. When reporting the amplitude for this function, you would just say the amplitude is 3. However, when using the amplitude in this way, we will want to consider it being negative. So I'm going to multiply by a -3. That will give me -3, 0, +3, 0, and -3. The amplitude from the baseline is now 3, but the negative does matter because that does flip the values. Next, for the y values, I'm going to apply the vertical shift. The vertical shift is the value of +2 that we have in this case, and that's what I'm going to do. I'm going to add 2. That will give me -1, 2, 5, 2, and back down to -1. These 5 values over here will correspond to my new y values, or my new y coordinates. Once I find the x coordinates and pair those, I can make my graph. So, over to the x values. The first thing we're going to do for the x values is the effects of the period change. The period change is the value that we have factored out of the inside of that function, which is the 1/2. However, unlike the amplitude, I'm not just going to multiply by that, I'm actually going to divide by 1/2. So I'm going to divide by 1/2 for each of these values. Dividing by 1/2 is actually the same as multiplying by 2, which means all my x coordinates are now going to be 0. Pi halves divided by 1/2, or pi halves times 2, is pi. Then we get 2 pi, 3 pi, and 4 pi for the remaining values. After the period change, we lastly apply our phase shift. The phase shift here is the value that we have that is adding or subtracting x. And this phase shift actually implies that we are moving to the left because we have a plus in front of it. So what we're actually going to do is subtract by pi halves. You will tend to notice the operations that we do to the y-coordinates are a little bit more straightforward for what you see in the function, whereas the operations you do to the x-coordinates are typically the opposite. I see a plus pi halves in the function. I'm going to actually subtract by that, which will now give me negative pi halves, 3 pi halves, 5 pi halves, and lastly, 7 pi halves. With these values, we can now create our graph. Starting with my first pair of coordinates, I have negative pi halves and negative 1. Negative pi halves is between 0 and negative pi, so that puts me about here. My second coordinate is pi halves and 2. Again, this last column here are my x values. So pi halves and 2 here would put me about there. Pi halves being between 0 and pi. 3 pi halves and 5. 3 pi halves is between pi and 2 pi, which puts me about here. 5 pi halves and 2. 5 pi halves is between 2 pi and 3 pi. Puts me about here. The last coordinate we have is 7 pi halves and negative 1. Puts me about here. If I connect these using a continuous smooth curve, so not one with sharp angles, I'm going to get something that looks kind of like this. What we have graphed is one period or one cycle of this function. This function would continue and continue to create this periodic shape. If you use a different method to come up with a different period or cycle, that would be acceptable. However, you may note that the function for cosine normally starts at the peak and then comes down and back up, whereas this seems to be doing the opposite, starting at a bottom of the function and then going up. The reason for this change is because of our negative amplitude. If you notice, this means that our graph has now technically flipped over this midline, which we now have at y equals 2. That flipping over the midline is because of the negative we have on our amplitude.